What's up, everyone? Good morning, good afternoon, good evening, depending on where you are. I am Sam Charrington, founder of TWiML and host of the TWiML AI podcast, and I'm here to welcome you to today's webcast. Go ahead and get yourself settled in, get yourself comfortable. Well, once again, welcome everyone. I'm super excited to get this conversation kicked off. My guests for today's webcast are Juhi Dhingra and Dunja product managers working on the batch and streaming platforms at Intuit. So today's session is a bit of a follow-on to my conversation with Srivatsan Kanchi, former head of engineering for ML platform at Intuit. That was back in 2020, and we spoke about the feature store that they built and launched at that time. And while we don't often go deep into the data engineering side of things on the podcast, the feature data does need to come from somewhere. And so we thought it'd be interesting to explore the platforms that enable it. And so in today's webcast, we'll be exploring Intuit's batch and streaming data platforms, the various use cases they serve, how users decide which of those platforms meets their specific needs, how they support feature generation for machine learning, and we'll be digging into the team's plan for the future, including creating a unified platform for batch and streaming feature generation, as well as the ability to offer low-code and no-code options for their users. Before we jump in, I'd like to share a few quick announcements. The most important of which is that we are just under a month away from TWiMLCon AI Platforms, the premier conference for practical enterprise machine learning and ML ops. I invite you to join us October 4th through 7th, along with fellow ML and AI practitioners and leaders, as we explore real-world challenges and solutions for developing, operationalizing, and scaling machine learning and AI in the enterprise through a wide range of technical and case study sessions, live podcast interviews, in-depth workshops, and panel discussions. Qualified attendees can still apply to attend for free by visiting twimlcon.com. I hope to see you there. All right, at this time, I'd like to welcome up our presenters, Dunja and Juhi Dhingra. Dunja, while we're getting the slides set up, I'd like to remind our audience that, of course, we want this session to be interactive and that they can submit their questions throughout the session via the Q&A panel. I'll also be keeping an eye on the chat as well, if that's easier. And we'll be working really hard to get those questions worked into the conversation. One last thing before we dive in, it's become a little bit of a budding tradition for these webcasts to start them off with a dad joke, my favorite variety, just to remind us all that we're here to have a good time while we're learning and to not take ourselves too seriously. And so my first question for you, Dunja and Juhi, is what do you call an acid with an attitude?
Sulfuric acid.
That's a good guess, but not the correct answer.
No idea. Tell us, Sam.
Amino acid.
Oh, that's a good one.
That's good.
All right. I'll hand things over to you, Juhi, to start introductions, and then we'll dive into your presentation.
Sure. Hi, everyone. My name is Juhi Dhingra. I work as a senior product manager at Intuit. My primary focus is on data processing, and I love building impactful product experiences to delight our customers. Over to you, Dunja.
Awesome. Hi, everybody. Thank you so much for joining us. And Sam, thank you so much for having us. My name is Dunja, and I'm also a product manager at Intuit, also working in our data processing space. We're so excited to be here today, and I can't wait to kick it off with you all. Let me share my screen. Can everyone see it?
Yes, we do see your screen. If you're not seeing the full slide, make sure to use that view option to fit it to your window.
Great. All right. Well, with that, we will kick it off. So here's kind of an overview of what we'll hope to cover today. We'll talk a little bit about the need for data processing tooling. Then we'll talk about the products that we support, batch and stream processing platforms. We'll talk through a couple of our use cases and when to know when you should use stream versus batch. And then we'll talk about the path forward. But to kick us off, I want to just ground us in the problem space at Intuit. So Intuit, as you may or may not be aware, provides financial software such as TurboTax, Mint, QuickBooks, and we provide that to individuals, businesses, and accountants. We recognize that finances can be a universal challenge for everyone, and so our mission is really to power prosperity around the world. And specifically, our team focuses on this mission by accelerating the development of AI and data-driven solutions so that our customers can have access to the right information at the right time so they can make decisions that'll save them, that'll make them more money, that'll save them time, and that'll help them make those decisions with confidence. To get more concrete with an example, we've built an AI-driven expert platform. So we connect people with experts so that our customers can get the insights that they need for their unique situations. To do something like this, we need tooling that can make sure that we're writing the customers to the right experts at the right time so that they can get a quick and accurate solution. And that's really where data processing tooling comes in. So that kind of orients you around the problem space, but I will now just go into a little bit about how we get there. So I'll start with a bit about the data journey. So raw data will come in from a variety of different sources. It can be third-party apps from services, and that data will then get sent to our data lake or event bus, which is our event store for our streaming data at Intuit. Then a data engineer will come in and they will actually write processing code that will actually transform that data to meet their specific use case. We have data engineer called out here because that's the persona we've primarily targeted in the past. But as Juhi will allude to later, we're really trying to broaden the scope to both data analysts, data scientists, all data workers. But for this purposes, we have data engineer called out. And once they author their processing code, they will then select a runtime for their application. And depending on if it's a batch or streaming use case, they'll actually go ahead and schedule that. For streaming use cases, the data is always flowing, and so your application is always on, always running. So there's no need to necessarily schedule anything in that case. Once the data engineer has gone ahead and transformed the data, cleaned it, they will then send it to a different data sync, whether that's the data lake, the event bus I mentioned recently, the feature store, which is where we house all our features, a data warehouse. They'll send it to one of many places potentially, and then from there, it will go ahead and be used to power different use cases, whether that's dashboards for analytical and reporting purposes, or even powering some of our use cases like the virtual expert platform that I mentioned earlier. And then we get into sort of why the problem space and why the need for this. So there are over 60,000 data processing workloads at Intuit. And a big chunk of that time is actually spent managing the infrastructure or doing DevOps work by our data engineer customers. So Juhi and I are really focused on how do we simplify that for people so that they can build their applications as quickly as possible so that they can deliver insights for our customers as quickly as possible. And so now I will talk you through sort of how the platform works. So imagine you're a data engineer. You want to focus on creating your data processing applications. You want to use that to power in-product experiences. That's what we call the tip of this iceberg. But there's a lot that actually needs to happen to be able to do that. If you were to do this from scratch, you would need to set up your own access and governance, figure out how to handle compliance, set up your own monitoring dashboards. There's a lot that actually would need to take place. that multiple teams would have to do over and over if they were to each do this individually on their own. And that could take up to 3 months to get something in production. With our platforms, we're handling all of that for our customers. So we set up the monitoring dashboards, we handle access and governance, we take care of compliance, we set up the cost and billing, and we also do the infrastructure management. So that's scaling up the resources to actually run these jobs and workloads. That way, our customers can really focus on their use case and what is the business logic that they need to author to run their use case, and we'll handle sort of everything on the bottom of the iceberg for them. And in terms of how does this actually work, at Intuit, we have a developer portal where anyone can come and sort of access it to go ahead and create any applications out of the box. Specifically within this developer portal, we have 2 resources. One is called a data processor, and the other is called a data pipeline. So in order to create a stream or batch application, you would first need to create a data processor. The data processor actually houses your code. That's where you would write your transformation logic. And then you would attach that to your data pipeline, which is then the actual cloud deployment of your application. And by offering this out of the box through developer portal, we're able to help people get set up in what could previously take months. You could create something like this within a matter of minutes, and then from there take it to production. And then we just have a few of the features called out here for folks who prefer more automated solutions. We have APIs that they can leverage instead of going through our UI. Like I mentioned, we'll handle the compute. We offer a number of programming languages that we support, Java, Python, SQL, and we also offer starter code so that people have an example to get up and running. So these are just a few call outs in terms of what the platform actually supports. And then in case you're curious what the tech stack looks like, there are a number of technologies here to sort of make sure that everything is running and functioning the way it should. In terms of what the customer sees and interacts with, GitHub to write their code, we offer a number of tools so that they can actually monitor the health of their applications and also use those to debug, like Wavefront and Splunk. And then there are processing frameworks that users will interact with to actually set up their application. And then everything sort of below the iceberg is something that we will handle on behalf of our customers, but that's running behind the scenes to make sure everything is working as it should. And then let me talk through one of our examples. I'll kick it off with a streaming example, and then I'll turn it over to Juhi to do a batch. But so in this example, imagine you are a QuickBooks customer, and you are hoping to, it's your first time sort of interacting with QuickBooks, and you're feeling a little overwhelmed because there are a lot of features and you're really excited, but it can be definitely sort of an overwhelming experience if this is a completely new space for you and you're just starting to interact. So what we've done is we have created this streaming application where essentially anytime a user is logged into QuickBooks, based on sort of how they're interacting with QuickBooks, we'll go ahead and actually show them more personalized recommendations for self-help. So before, when you were trying to navigate and find things on your own, now you can see certain suggestions that are based on what you've been browsing. And that's really cool because we've been able to see increases in our engagement rate or click-through rate. And most importantly, this has also reduced the number of times customers have had to reach out to customer support to get their questions answered. And the way this kind of works behind the scenes is we are using clickstream data from our event store. That data is coming into the stream processing platform which is creating those features. Those features are then stored in the feature store and used as inputs to the self-help models, which are built on our model execution engine. So that's kind of a high-level overview of what this looks like in action on the streaming side. And I'll pass over to Juhi to talk about batch.
Thank you, Dunja. So let's talk about this batch use case. One of QuickBooks' mission is to become the primary method for cash flow management for our SMB customers. We accomplish this by providing insights for our customers to understand their cash flow holistically and then make smart money decisions. In many cases, this includes use of AI to generate predictions and insights, as well as intelligent recommendations for our customers. In this case, the cash flow data is ingested into the data lake. Data is enriched to create machine learning features via batch processing platform. The features actually are then made available to power the machine learning models. And finally, the data goes into customer C360. It publishes the content to our target users via QuickBooks Campaign Manager tool. So that's how we are disrupting the small business market, helping our customers make better decisions for their cash flow. Next slide, Dunja.
Before we go beyond the examples, I want to ask a question of my own, as well as one that was submitted from the audience. Starting with Govind's question, you mentioned in talking about the platform that there's a billing component and that you do that on behalf of users. Can you talk a little bit more about that? This is an internal platform. What kind of billing information are you tracking, and why is that important?
Yeah, absolutely. I can take that one. So if you think about a streaming application where your data is always coming in, your data is in motion, and it's always on, that actually requires a lot of compute setup, memory setup, and also dependent on other resources. Not every team is necessarily using at Intuit is using the streaming application. So in terms of the billing that we're supporting, it's to help each individual use case appropriately make sure that billing is set up for their specific needs to power the use case that they're supporting. If they were to do this on their own, they would also have to set up billing with the infrastructure providers that are spinning up these jobs.
And so are you primarily tracking the downstream infrastructure charges, AWS or what have you, and then kind of presenting it back to them so that they can manage their application resources? Or are they kind of paying for your platform as a service independent of the infrastructure usage?
Yeah, it's solely on infrastructure usage. And it's as simple as you would just specify, hi, I'm an XYZ business unit when you're setting up your application. And then you'll just get the charge based on your individual usage of your infrastructure resources later.
Yeah, you had a stat in there earlier about 35% of the ML and data users of their time being spent managing infrastructure. And it made me think, like, we say 80% of their time is wrangling data, and now 35% of their time is managing infrastructure. Like, when are they ever gonna, do fun stuff like build models and get them into production? But thinking about like all of the infrastructure work that needs to happen to enable these applications, and then the ongoing management of their costs, I can see why you would want to offer that capability. Another question that I had was around, you mentioned that one of the key components is this idea of a data pipeline that allows the user to filter and transform data. I know that there are machine learning platforms at Intuit that also offer these capabilities, as well as other tools. And I'm curious, how do folks determine where to implement transformations when they're building applications?
Yeah, I can take that question. In general, yes, there are a lot of tools that are there in the space of ML world today, and it's actually up to the users. We leave it up to the users to pick and choose the tools that they're feeling most comfortable with. But in the whole data journey, we are heading towards building a good data mesh, which would have proper access, governance, metadata, proper validations like schema validations, data validation, idempotency principles, all to produce good, clean data sets. To get to that data mesh vision, we actually do want our customers to use the PavePart tooling. So how we suggest them is go ahead and use the tooling that is available for your training and model development purpose. As soon as and there's a need to use the tooling, some of the tooling which is outside our PavePart tooling today. Sometimes users feel more comfortable with it. Sometimes it's just that new features are getting rolled out in external tools, and our products are not yet at that stage. So we give that option to our users. But then to productionalize their data, we ask them that you should productionalize using the PavePart tooling. Do your testing, train your features, bring them up to the place where they are good enough to power the machine learning models or good enough to run analytics, and then go ahead and productionalize them using the PavePart tooling.
Got it. Okay, thank you.
Okay, I can take this slide now. Now let's see how we actually guide our users to using batch versus stream for feature creation. So it really depends upon the use case, right? You are coming in and you want to do some analytics. Let's take an example of clickstream analytics where, users are using your application and the data is coming in continuously. You would want to use stream processing platform in that case. There are places where you want to run monthly reports, hourly reports. For that type of analytics, we ask our users to use batch processing platform. Then there might be marketing or in-product personalization that you want to offer. The use case of cash flow forecasting, which we just discussed, is an in-product offering for our users. It shows insights inside the product and people can make decisions. Now, those insights are created again in batch fashion because the use case requires those insights to be created in batch fashion. Then there can be forecasting or predictions that you want to derive out of a certain data set that's available to you. And how that would happen is I can give you an example. So let's say our users are coming in and using TurboTax application. We want to see how many users are leaving TurboTax every year, right? We have the data across so many years, and now you want to drive predictions out of it to understand how many users will leave TurboTax in the next year, right? In the next tax season. So it's fair to go ahead and do your batch prediction, run your model as soon as the tax season gets over and derive insights out of it. And then see what you can do about those insights, right? Offer some personalization to your users, offer some discounts to your users, and so on. And then we have chatbots. Chatbots is a fair example of using real-time processing. If you have any user coming in using your application, they ask a question. Based on the data that you have for that user, you immediately respond using chatbots. That's how it depends upon your use case, but it also does depend upon the data itself too, how fresh the data is, how frequently it is coming in. For continuous data, continuous streams, we recommend using stream processing because that will help you to produce clean data, fresh data all the time in the data lake, and it can be consumed by the downstream consumers in that manner. And for the data that is coming in hourly manner or in monthly manner, we ask people to use batch processing. Stream processing also does have a higher cost associated to it because of the infrastructure, and it's always running. So we ask users to take decisions considering all of these factors. Next slide.
And on that last point, I imagine that there's a fairly significant gray area of applications that could be either batch or streaming. Does it end up being primarily cost driven, or are there ease of use considerations, or are teams mostly thinking about kind of future directions when they make those decisions?
Yeah, so most of such decisions are cost driven. What is the return of your investment, right? If you want to build something, do you have enough budget in your business unit to take that decision? And it depends upon the use case. What's at the end of the day, how much money is Intuit going to get out of it, right? So um, doing that kind of calculation and that kind of analysis, how users are going to use it, I think it's very important to take such decisions combined with how much cost it's going to incur for your use case to run.
And are the costs primarily infrastructure costs again, or can you elaborate a little bit on the cost differential and how significant it is between the streaming and batch use cases?
Yes,
Or
the
infrastructure?
cost is the cost is mainly on the infrastructure side, and doing a comparison, we really don't do the comparison unless the users are really confused as to what they want to use. Most of the times, use cases do drive it out.
Mhm.
Take an example of an Amazon EMR, right? An Amazon EMR would run we use transient EMRs. We try not to ask people, we try not to use persistent EMRs. There are very, very few cases which are using persistent EMRs. So
Using
in
what
terms of
EMRs?
persistent EMRs
Oh,
plus
persistent.
persistent
Got it.
clusters,
Yeah. Yeah.
persistent infrastructure clusters. So what happens with that is that when your clusters go up, when your job is running, we switch on the clusters, we run those jobs, and as soon as the job ends, the cluster actually shuts down. So it's not an always running cluster. You won't have to bear the cost of running the cluster. You would actually only pay for the time the cluster is running. And for streaming, that equivalent cluster is always running. So you always keep incurring cost on top of that.
Got it. Okay, thank
And
you.
I'll just add, Sam, it also depends on the event traffic of your data. If you have a lot of data coming in and you need to process it very quickly, you're going to need more compute, more memory, and that's going to end up being more cost. So it is really use case to use case specific, just because it can vary so much across teams.
Great, thank you.
Okay, taking us to our path forward. Dunja has very nicely explained how batch and stream processing platforms work today. However, there are still problems in the overall data platform that we have. We still have multiple toolings that people are using. We are still not there. We have not still given those paved paths to our users. So general issues that we still see today are around onboarding the data, getting it into the data lake, getting clean data, using clean data, having access, having governance, having quality monitoring set up on the data, enforcing ownership for the users to own that data and answer questions related to that data. Because of bad data in the lake, our users are not able to trust the data, and hence they are not able to consume it properly. Imagine that you have 3 to 4 different data sets. You look for some data and you find 3 to 4 same different sets. One is in S3, one is in feature management platform, and there's another copy in S3. It becomes difficult for me as a user to understand which one of the data sets should I actually go ahead and use. So that makes trusting the data very challenging and difficult to consume. The future where we are headed towards is a connected path future where we ask the users to discover data via our data exploration tool, and then produce data through one single system for stream and batch processing, and then publish the data into feature management platform or data lake or Redshift or Event Bus. And with our analysis, what we found out is that today it takes months to consume data which has been produced by our users. And we want to bring that number down to just a few hours. Next slide, please. So we are entering into the world of data mesh, where we are, imagine, that there's a team that owns a certain data set. And that data set, they are responsible for answering all the questions related to that data set. That the data set actually belongs to a certain domain. For example, QuickBooks. QuickBooks can have invoices. So my data belongs to invoices domain. And now I do have a data product created out for the invoices. And this data product can be used by my downstream customers. Now, what is a data product actually? A data product is a set of internal processes and data that produce external data, which can be consumed by downstream consumers. It has infrastructure, governance, compliance, access, everything associated to it and taken care by the platform itself, including the data set. All of this is called as a data product. When the data is produced, data sets are produced out of a data product, you get clean data, which is good quality, and then you're able to see the connections with the upstream data products, downstream data products, and you're able to discover that data. You can go and search for the data, look for the data, and you can also see how people have used that data. You can go ahead and check out the transformations or the code that was behind producing that data. So now go ahead in the next slide. I'm going to walk you through a user journey, a very quick user journey of how a user experiences this when they come to our tooling, our future state tooling. So this is our data discovery application. And I, as a user, come in, I want to look for a feature set here. And I type, I'm looking for QuickBooks Invoices table or a QuickBooks Invoices Kafka topic. And this is an entity. I make a search and immediately I see a lot of results coming in. So I read the description about it. The description says that this particular entity was created for this particular business purpose. And then there's a steward associated to that entity. So I can go ahead and ask my questions to that steward. It also tells me how fresh that entity is. It has been created a month ago or 2 months ago and so on. Now, go on to the next slide. If I click on that entity, it actually tells me additional details. It tells me does it have sensitive data? It can be 7216 data. It can be private data. Does it exist? Does it have a corresponding table associated to it? Then which domain does it belong to? You can see the business purpose here as well. And I want to now go ahead and see what attributes are there within this entity so that I can use the specific attributes that I want for my use case. So I'll go ahead and click it. Go on to the next slide. Here I see the list of attributes that are available for this entity. I see that there is sum of invoice balance. I see there's count of deleted invoices. I see that there's count of line items lifetime. And there's a purpose for each of these aggregations or each of these attributes which were derived in this for this particular entity. And I also see the popularity, and if I want to use this, I can go ahead, use this. If I don't want to use it, I want to create something else for my own business purpose, I will go ahead and click on metric. When I do that, you see, I enter into a screen called as Data Map Studio. The Data Map Studio lets you author your transformations. I'm coming from data discovery tool. So this, I'm actually able to see input already selected as I had made a choice of using a certain entity. So entity selected as an input. There's a transformation also selected, and I can choose whether this transformation has to run in real time or it has to run in batch. If I am choosing real time, there will be no schedule associated to it, obviously. And then there is hosting locations. The hosting locations can be Customer 360, it can be FMP. Now, if you look at the very top of this entity, this is a draft mode entity. This entity has a business purpose associated to it. And then you have your input transformation out and hosting location, this modal. This tells you that you are actually creating a data product. There is infrastructure behind this entity. This infrastructure, in case a user is a data engineer, they would want to optimize use of this entity, use of the infrastructure resources. In case an analyst is using it, they wouldn't have to enter into that hassle, right? So you will also see at the top that there are tabs. This recipe is the authoring tab. And then there is runs. So whenever this particular recipe runs, recipe is equal to a pipeline in our terminology. And when this pipeline or this recipe runs, you get a report of it. How many runs have happened? And is it running continuously? Are there any issues in any of the runs? You can go to Splunk. You can debug your issues right there and then. And then you have quality tab. Quality tab tells you that the quality of the data is good or it is not good. Are there any missing entries in a certain period? It checks parity with the source. You also have a schema. We do enforce schema validations as well. And we enforce a certain schema that we want all schema standards that we want all our users to follow, so that there's no discrepancy between the schema standards. There is relationship tab, which guides your relationship between different data products. Like it can be an upstream data products that you are consuming from, and to creating a downstream data product from this entity. And at the end of the day, you are able to share this recipe with your customers, with your team, and you can actually do a dry run and publish this. Once you feel that this is good enough, you can go ahead and publish this. So that's how we are building a connected system from data discovery to exploration to producing new features. Next slide, please. I'll close us out with a summary from this slide. And this is our next 2 years in a nutshell. We want to provide simple and well-integrated, easy to use data processing experiences. We are trying to solve current problems which exist around integrated experiences with access, discovery, exploration, model development, and seamless transition from getting the data, discovering the data into lake, into converting the data into an analytics report or running continuous analytics on it. And then building one single experience for stream and batch processing. Today, stream and batch processing worlds are two very different worlds. They don't have to be. If someone is authoring a transformation, they should have a choice to run it in stream or batch. Like Sam, you pointed out that there can be use cases which can run both stream and batch. It's up to the users how they want to configure, and we don't need two systems for it. Then we also want to ensure faster delivery times. We want to expand our persona from data engineering persona to a very non-technical persona also, which can be marketing analysts, which can be data scientists, and offer them default optimizations through the product. We want to promote reusability in future. With the transformations which have already been done by other users on the platform. So let's say that you have built an aggregation that can be used by somebody else. They should be able to use it. They should be able to extend it. So we want to offer that kind of reusability through the operators, reusable operators in our platform. And at the end of the day, we want to build a very well-connected data mesh to track all the lineage, the journey of the data itself, how it is coming into the application, how it is getting processed, and how it is landing into various reports, or how it is actually landing into the in-product experience for our end users. That's all. I think that's what we have for today. Thank you very much for listening to us. And if there are any further questions, we'd be happy to answer them.
Absolutely. This is a great time to remind our audience to submit your questions via the Q&A panel. Thanks so much, Dunja and Juhi. We do have some questions. Another from Govind. The question is really about the kind of the relationship between the platforms that you've discussed and the feature store at Intuit. Are all models built on features that are coming from the feature store? Or I think you mentioned some other places that people can publish data products to, or publish data to. If a user wants to create a new feature, what's the process to do that? What are the access and control and governance mechanisms in place to manage this? And I'll let the two of you answer this, but we also, I think, got a surprise guest response from Srivatsan
I can see that.
in
Yes.
the Q&A panel, and I'll
Yes.
let folks, check that out as well. But what's your take on it?
Yeah, so yes, we do have a feature management platform that's already available. The feature management platform offers capabilities, right? Access related capabilities. It enforces schema standards. We do ask our users to use that, and our feature management platform is available in both DynamoDB as well as in Data Lake. So users, if it's an offline model, we ask our users to go ahead and use the data lake version. If it is real time, they should use the online feature management platform, which is our DynamoDB version. It ensures monitoring. We ensure the SLAs that the features are getting created in time. You're able to access them easily. It ensures ownership principles as well. So our guidance to our users is go ahead and use the feature management platform using the batch and stream applications. Feature management platform is basically a storage of data, and it ensures principles on top of it for that data. The data you would go and search, you will be able to immediately find that it has which data is private, which is publicly consumable, which is what data is actually has 7216 compliance or SOX compliance associated to it. And then you can judge that, do you really need this data? And if you do need this data, who do you have to go and request access to? So all of those principles are already built on feature management platform, and hence we ask the users to go ahead and use that. But yes, if they don't want to use it, you can definitely store your features in data lake. You will all of these principles do not directly are not directly present effectively on data lake, because in data lake you will find internal data products which are getting created for some purpose in the intermediate stage, and then you may be using those internal data sets to deliver something externally consumable. So to keep everything clean, feature management platform is the place to go and put the features in. Dunya, anything you want to add?
Yeah, no, I think you answered it well, and I think Srivatsan also answered it well in the chat. We have these paved paths to make it super easy and simple for people to create features. It's really as soon as you start using either the stream processing platform or the batch processing platform, you're able to write sort of those outputs to the feature store, which then super easy to then move those to our model execution system. I'll just call out that obviously there's a whole lot of work involved in determining like what actual data sets do I want to use, who's like in charge of governance for those data sets, how do I get access? So there's a lot of work involved in the setup, or even like what features do I want to test? But in terms of actually going and generating the features, yeah, the paved path platforms that we discussed today are the ways to go.
Got it. There was a question that Ted asked about whether the feature store is internally built or did you buy a vendor product. Juhi answered that it's internally built, but I'd ask Amari or someone on the team to drop in the link to the interview with Srivatsan that goes into quite a bit of detail into that feature store, how it was built, the collaboration with AWS around that. Lots of great information in that conversation. Juhi, you mentioned, or maybe both of you mentioned, that one of the offerings of your platform is data lineage, an important topic for many use cases. And the holy grail there is to have lineage from some prediction that a model makes all the way back to the data source. And that kind of raises questions about, you've got the data platform, you've got the feature store, like how do you offer that end-to-end lineage? Do you offer that end-to-end lineage? And if so,
Yes.
how, and what are kind of the challenges and solutions that you came up with to do that?
Yeah, we do have a tool called metadata registry. one good thing is that everything writes to metadata registry. Most of our PavePar tooling, not the external tooling, but that our users use, which is probably about 5 to 10% use cases. But most of our PavePar tooling does write to metadata registry tool. And there, when the data gets ingested into the lake, we have a ingestion platform that writes to metadata registry. We do have a batch processing platform, stream processing platform, writing data, which is getting produced at every stage inside a pipeline, written to metadata registry. We call it as MDR. And then this lineage is showcased through the discovery tool, as I said. So when you will try to explore the data, it will show up that you can trace back into how the data was getting created. And then obviously, now we are also trying to link, by moving to data mesh principles, we are also trying to link code as well as infrastructure into that registry. So any point of time, if I want to go ahead and I want to check how this data was even getting had even gotten produced, I can actually go and check the code out associated to it.
Okay. A question from Diman. Are there any plans to extend the platform to be multi-cloud to give users choice of where their analytics are running?
Yes, we are exploring. Right now, we are an AWS shop. We are exploring Google Cloud. The reason we are exploring Google Cloud is because Intuit has acquired a couple of companies right now, MailChimp and Credit Karma, and some of them you do use multi-cloud strategy. So yes, we are exploring it right now. We are in very initial phases, and we don't know yet we will be going multi-cloud or not.
Got it. You mentioned in the presentation that you do, one of the features that you're offering is schema validation. And I'm curious if that is primarily at authoring time, or are you also doing runtime schema validation so that, and this may be more of a feature store capability, but so that if the semantics of a feature change over time, that doesn't break a model that's into production?
That's absolutely true. We do runtime schema validations, and we have a standard of schema coming in, and we want all of our tooling, including feature management platform. I also mentioned customer C360, event bus, to all follow those particular standards. And we call it as IEDM, entity schema definition standards. And those schema standards are going to be consistent all across. So at the time of authoring, if any user is introducing a breaking change, we immediately warn the users by checking the input schema and saying that this will introduce a breaking change to your model or to your feature set which you're trying to generate. So we warn them, and we want to reach a stage where we don't allow that breaking change to happen at the time of authoring.
So does that mean that you don't necessarily need to maintain a dependency graph of data products and applications that use them? Rather, you just can focus on the schema as being a contract, and then
No, I think both serve different purposes, right?
Okay.
We do want to maintain the graph of all the data products which are getting created. So that graph is necessary to understand how the data is coming in, and what code and infra is associated, who's the owner. So it's an important graph.
Mm-hmm.
But then the schema validation itself is to ensure that you don't make any breaking changes to your schema, because there are downstream consumers. So be aware that your product, your data product, is also being used by a downstream consumer. And if you do any breaking changes, you would have impact on those data products as well. So that's what we want to enforce, and we don't want to allow users to make any breaking changes.
Yeah. And do you end up with, as a result of that, many versions of particular data products that need to evolve slightly for one group, but can't evolve for another group? Like, how do you handle the frictions that arise when you're productizing these, potentially dynamic elements of data?
Well, that's a good question, but it's not dependent upon the schema of the data. A breaking change to a schema can actually cause bad data to get created, right? So we don't want that to happen. It's important for us to give guidance to the users. But yes, if they do want to create a particular, they do want to have a particular use case for which the schema needs to be completely different, they should create it as a separate data product itself, right? It should be created as a separate entity with a new schema.
Mm-hmm.
So it depends upon the use case as much as it depends upon how you are handling your schema.
Yeah. I'd like to remind folks that we do have a few minutes for additional questions if you'd like to sneak one in. I did want to ask about, in your roadmap, you talked about the paved path and kind of a desire to eventually offer low code, no code types of solutions. And I'd love for you to elaborate on that. Like, what's driving that? What do you expect the main challenges to be? That kind of thing.
Dunja, do you want to start off and I can join in?
Sure. As sort of mentioned in the earlier part of the presentation, we have primarily focused on the data engineer persona, just because this is a very technical space and each use case has its own, considerations. We recognize the power that comes with data. And so to that end, we're really trying to broaden the number of employees who can take advantage of these types of tools. Not just data engineers, but data scientists, data analysts, product managers, marketing managers. Like, these are tools that should be available, to the entire organization. And part of that also comes with making it more accessible and more easy to use. And so that's really driving the need for this focus on low code, no code. Juhi, I don't know if you want to add anything to that.
Yeah, just to add, we want people to derive aggregations or derived attributes very quickly. There may be a use case where you don't need an engineer to work on something. And I, as a marketing manager myself, is able to do it. As much as I know my entity, I know what data, because I'm most close to the use case that I want to build as a marketing manager, as a product manager. If the data is very clean, it's in the lake and I'm able to discover it, I should be able to very quickly drive basic, very simple workflows out of it. Right. So that's the intention that we are going ahead with. We are not targeting very complex use cases for low code, no code, but simple aggregations, simple attribute creations for real-time usage, for batch usage. We don't want a dependency to be created for just to do simple use cases to our data engineers or ML engineers.
Got it. Another audience question related to my previous question around data versioning, and I think it's part of it is pointing out this maybe overlap between data versioning and schema versioning, which are two different things.
Yes.
Data versioning is often brought up in the context of solving problems like lineage, for example, and provenance. But the question is specifically asking, is data versioning for cases that is it supported for cases where there's not a totally different schema, or if it's just a variation of the existing data?
Sure. Let me give you an example of that, right? Let's say that you want to build an invoice. You have an invoice entity and you want to build an attribute for an invoice entity. It's an additional attribute you want to add to an invoice table. And probably that attribute will tell you that how many active invoices are present today in the system, right? And then it will also give you another attribute, which will actually give you a count of inactive invoices that are present in the system today, right? So You want to use the existing entity, you want to extend the existing entity, you will go ahead and extend the existing schema. When we talk about, so you will definitely have a new version of schema created to power that use case. And you don't need to create a new entity. You can use the same entity, you can use the same recipe, you can use the same pipeline, you can extend your transformation to power new aggregations. But let's say that you want to delete a particular aggregation because it's of no use to you. And you don't know whether it is being used by a downstream consumer or not, or maybe you didn't check. So the system basically says that this is a breaking change because this particular attribute is being consumed by a downstream consumer. So we won't let you do this breaking change. That's the difference between how a schema validation happens and how our users basically extend the schema. What cases are allowed, what cases are not allowed.
And do you support data versioning? Where you're snapshotting data so that a data scientist can say, okay, when I trained my model at this time, this was the exact set of training data that it was trained on, or is that done in the ML platform or a feature platform or someplace else?
That is supported in the feature platform that we don't support via data processing tooling, but yes, it's supported in the feature platform.
Got it. Well, I'd love to close out by having you both comment on kind of some of the biggest lessons learned here, and for folks that aren't as mature as you in this space, what are some of the key takeaways or shortcuts that they can take when they're trying to do what you're doing, democratize access to data for their teams?
Yeah, I'll let Juhi kick it off and I'll close.
Sure. So I think it's very important to understand how understand the space that you are in, right? Understand that, yes, there are principles out there which will guide you. Data mesh principles guide you in a certain way, but I think it's very important to understand your own data lake, your own data. What tools do you have today? What tools are useful? What are not useful? We've seen a plethora of tools developed at Intuit for doing one single use case, and I would suggest not entering into that domain. Try to keep the solutions as simple as possible, and try to develop something which can be used by not by single persona, by multiple personas. And we are dealing with it right now. So that's a lesson learned. Consider, so know your space and then follow the principles, but don't stick to them. The moment we start sticking to the principles, there are places we start falling behind. And modulate those principles as per your needs, as your platform wants you to, as your users want you to. Achieving and catering to achieving the goals via providing a good data platform by catering to your user needs is the best way to addressing the pain points around data.
Yeah, I will I will echo that. I think it's really, really important to understand the types of customers you're building for. If you're building for a data engineer, that's a completely different product than, let's say, a data analyst. And so it's important to keep in mind what different groups are going to need. And I'll also just say it also depends like where your organization is trying to go. Sometimes there's a need to balance like speed with, let's say, governance. Do you want people to be able to move quickly, or do you want to be more thoughtful about like how you set up controls and access and everything from the start and get go? So I think it's all really going to depend. I think having that principles document of like, here's what we are going to focus on and what we're going to solve, and here's what we're not going to tackle for now, I think is really important. And then backing that up to the customer that you're solving for is going to be critical. So it's a little high level guidance, but I think it's important to keep in mind when you're setting up a platform like this.
Awesome. All right. Well, that is a wrap on this session. Big shout out to Juhi and Dunja for a great presentation and answering all of our questions. Also, a shout out to Srivatsan, who connected us and showed up and dropped in an answer. Much appreciated. And thanks, of course, to all of you for attending and participating in the discussion with your great questions. To stay up to date on the next of our meetups, our webcasts, visit TWiMLAI.com and sign up for the newsletter. And of course, once again, register for TWiMLCon at TWiMLCon.com. Thanks everyone for joining us today.